So in last class we had discussed on different aspects about the gyroscopic effects on aeroplane and for the disc also. So let us see how the gyroscopic couple will be acting on an automobile. So if you consider a four-wheeled vehicle and when it takes us a uh, turn, okay, so the condition which is going to be fulfilled on the vertical reaction of the ground with the wheels are positive, that is upwards. So what will happen here in this four wheel, when the vehicle takes a turn, automatically the weight on each wheel, that weight each wheel, that will be divided, because that will total weight divided by 4, because 4 wheels are there. So automatically will be the on weight on each wheel will be the total load divided by 4. So in this case you will be getting the weight on each wheel will be W by 4, that is mg by 4. So the reaction of the ground on each wheel will be W by 4, that is mg by 4, that is the upwards. So when the weight is downwards, automatically the reaction is going to be upwards, that is we take it as Rw. So next, if we see the effects of the gyroscopic couple, so you know that C omega is nothing but 4 into I omega and omega p, because of the 4 wheels which are there. So that will be nothing but equal to 4 into I omega, and if you consider the precision velocity omega p, so that is v square by r. So automatically you get this formula as 4 I omega v square by r into r. So I omega is nothing but the mass moment of inertia of each wheel, and omega w is nothing but the angular velocity of the wheel, that is nothing but v by small r, and omega p is the angular velocity of the precision, that will be equal to v by capital R. So v is nothing but the linear velocity of the vehicle, and where capital R is the total radius of the curvature. So gyroscopic couple due to engine parts will be CE, that will be IE omega p. So IEG omega p can be taken when the gear ratio can be taken as omega e by omega w. So total gyroscopic couple will be CG equal to CW plus minus CE, that is for the wheel also and for the engine also. So you can see in this figure, so total effect the front side, so 1 and 2 tire, that will have the RG, that is having downward value, and RG for the second wheel it will be having upward direction. So RC again opposite direction, whereas you can see RW having the same direction here for both 1 and 2, and in the rear side RG you can see the reaction is going to be opposite for 3 and 4 there, and RC also, and RW that will be again towards the upward side. So positive sign is used when the engine parts actually rotate in the same direction as the wheels, and the negative sign they will indicate that they are actually opposite. So assuming that CG is positive and the vehicle takes a left turn, so in this if we take a left turn and then the reaction gyroscopic couple on it will be little clockwise when viewed from the rear side of the vehicle. So the reaction couple is provided by equal and opposite forces on the outer and the inner wheels of the vehicle. So that is forces on the two outer wheels, that will be CG here acting on this, so that will be nothing but CG divided by W. So for the two outer wheels it will be downwards, CG by W, whereas forces for the two inner wheels, that is here inner side of this, so that will be equal to CG by W upwards. And whereas if you consider the forces of each of the outer wheels, that will be CG by 2W, and the forces of each of the inner wheels will be CG by 2W, that will be upwards. And then for the inner wheels which is opposite direction, so that for the reaction on the ground on each will be RG, that will be CG by 2W, that will be upwards, and the reaction of the ground on each inner wheel RG will be CG by 2W. So you can go through the figure, then you will understand how the things can be reacted. So if you consider the effect of the centrifugal couple, then centrifugal force you know that is nothing but mr omega square. So if you consider here m into capital R omega p square, so if you consider omega p as nothing but v by r there, so you get mv square by r there. So the force which is required to overturn the vehicle outwards and the overturning the couple, that will be mr omega p square into h. So it will be mv square h divided by r. So the force on each outer wheel will be cc by 2w that is downwards, and force on each inner wheel will be cc divided by 2w upwards. And whereas if you consider the force on each wheel of the outer wheels is similar to the weight on each of the inner wheels, it is opposite. So reaction of the ground on each outer wheel RC will be equal to cc divided by 2w, that will be upwards. Then the reaction of ground on each inner wheel, that will be RC equal to cc by 2w, that will be downwards. And so therefore the vertical reaction on each outer wheel will be w by 4 plus cg by 2w plus cc by 2w, that is upwards. And whereas vertical reaction on each inner wheel will be w by 4 cg by 2w plus cc by 2w, that will be upwards. Okay, so the conditions which has to be satisfied, so that when you take the reaction of the ground on each inner wheels may not be upwards, and thus the wheels are actually lifted from the ground. So for the positive reaction, the conditions will be such that this w by 4 minus cg divided by 2w minus cc by 2w, that should be greater than equal to 0. So therefore what will get, w by 4 should be greater than equal to cg plus 2 cc divided by 2w. So we consider that rw is nothing but should be greater than equal to rg plus rc. Okay, so if you consider this problem where each wheel of a four-wheeled rear engine automobile has the moment of inertia, so I is given there, and effective diameter of 660 mm is given there, so diameter is given, and the moment of inertia for the engine part is also given there, rotating parts of the engine, so 1.2 kg meter square, and then the gear ratio is given 3:1, and the engine axis is parallel to the rear axle and the crankshaft, which rotates at of the same sense of the road wheels. So the mass of the vehicle is also given, that is 2200 kg, and the center of the mass is given for 550 mm above the road level. So the track width also given as 1.5 meter, and you have to determine the limiting speed of the vehicle around a curve with a 80 meter radius, so that all the four wheels maintain contact with the road surface. So here with the given conditions, IW is given as 2.4 kg meter square, and then small r is given 0.33 meters, IE for engine part is 1.2 kg meter square, and mass is given 2200 kg, H is given 0.55 meter, W is given as 1.5 meter, and capital R is given as 80 meter. So the reaction due to the weight will be nothing but RW mg by 4. So the total weight divided by 4, so to 2200 into 9.81 divided by 4. So we will be getting 5395.5 Newton, that will be upwards. And the second one, reaction due to the gyroscopic couple, that will be CW, that will be equal to 4IW V square by R into R. So if you calculate this, you will be getting the value in the form of V square, because we don't know. So it will be 0.364 V square. So now if C will be equal to I G omega W plus into omega P, so from this you can calculate that will be equal to 0.136 V square. So Cg will be equal to Cw plus Ce. So adding this you get 0.5 V square. So reaction on each outer wheel will be Rg, that is for the outer part O, that will be equal to Cg by 2W, that will be 0.5 V square divided by 2 into 1.5. So that will be equal to 0.167 V square, that will be upwards. And the same way reaction on the each inner wheel, that will be RGI, that will be 0.167 V square, that will be downwards. So from this reaction due to the centrifugal couple, so Cc is nothing but mv square by R into H. So from there you get 15.125 V square, and reaction on each outer wheel will be equal to C divided by 2W. So you get the value as 5.042 V square, that will be upwards. And the reaction on each inner wheel, that will be RCI, that will be equal to 5.042 V square, that will be downwards. And for maximum safe speed, the condition which is satisfied, that is RW should be equal to RGI plus RCI. So from there if you substitute the values, you can get the value of V. So V finally is equal to 32.18 meter per second, and then if you convert in kilometer per hour, you get 115.9 kilometer per hour.